The strategy for this first one is to draw a triangle. If it's not in quadrant 1, what quadrant will it be in? Quadrant 4. How do we know it has to be in quadrant 4? Because cos is positive, and cos is positive in quadrants 1 and 4, but not in 2 or 3. So because it's not in quadrant 1, it must be in quadrant 4. When we draw the triangle, we always draw it back to the nearest x-axis so that we have a reference angle. Now, if cos is 3/8, we know that cos is adjacent.
Sorry for the interruption.
Hello?
Maria for me.
So since cos is adjacent over hypotenuse, you can label the adjacent side as 3, the hypotenuse is 8, and a squared plus b squared equals c squared will give you that this side is the square root of 55. Again, you'll get really good at doing a squared plus b squared equals c squared in your head. So 64 minus 9 is 55, so that's the square root of 55. Now, if we want to find sine of theta, well, you know that sine of theta is opposite over hypotenuse, so it'll be root 55 over 8, but because it's in quadrant 4, it will be negative. And tan of theta, because it's opposite over adjacent, will be root 55 over 3, and because it's in quadrant 4, it will be negative. So anytime you get a question that gives you one of the trig functions and asks you to find other trig functions, usually drawing a triangle in the proper quadrant, labeling your reference angle, is going to be key to solving this question. Is the point root 3 over 3, root 6 over 3 on the unit circle? Okay. For this one, we're going to use one of our 3 big ideas. Can you say what the 3 big ideas were? Well, actually, we're going to use 2 of the 3 big ideas. 3 big ideas. Sine squared plus cos squared equals 1 was another big idea. Tan is equal to sine over cos. That was a second big idea. And our third big idea, something with a circle. The coordinates on the unit circle are cos theta comma sine theta. So those are our big ideas. With those 3 big ideas, we should be able to solve this question. Is that point on the unit circle? Well, if it's on the unit circle, then this is cos theta, and this is sine theta. And if it's on the unit circle, then sine squared plus cos squared has to equal 1. So what does sine squared plus cos squared equal? Well, if we square the first one, we'll get 6 over 9. We square the second one, we'll get 3 over 9. 6 over 9 plus 3 over 9 is 9 over 9. So we can write a statement, since root 6 over 3 squared plus root 3 over 3 squared equals 1, it is on the unit circle. If you got something that didn't equal 1, then you would know it's not on the unit circle. So all points on the unit circle are cos comma sine, and cos squared plus sine squared has to equal 1. So if all of a sudden it didn't equal 1, then that would mean that that's not a point on the unit circle, and that's how we can tell. So here too, we could use a similar technique as we did to the last one by doing sine squared plus cos squared equals 1 and figure out what it would have to be to equal 1. Or we could use the triangle technique since we know that our x-coordinate is cos theta. And we're already told it's in quadrant 3. So if we draw it in quadrant 3, back to the x-axis so we can label our reference angle. And if we know that the x-coordinate is cos theta, we know the adjacent side would have to be 12, the hypotenuse 13. A squared plus b squared equals c squared. Do you recognize this triangle? No? It's a special one, like 3, 4, 5. It's the 5, 12, 13 triangle. I'll introduce you to some special triangles after this example because they're special. So we got 5, 12, 13. What is our y-coordinate? Our y-coordinate is always sine theta on the unit circle. What would sine theta be in this case? Opposite over hypotenuse. Positive or negative in quadrant 3? Negative. So when you use the triangle technique, you're not actually drawing, this point isn't a point on the unit circle right there, because that would have a radius of 13. Our unit circle is actually going to be really small here. It would be about like this. Does that make sense? Because if this hypotenuse was 13, my unit circle has to have a radius of 1. But we can draw a bigger triangle and still label the coordinates of this point being negative 12 over 13, comma, negative 5 over 13. Now, figuring out what quadrant an angle is in quickly can be very helpful because then you can tell whether sine, cos, or tan are positive or negative. So right now we're going to look at some strategies for just figuring out what quadrant an angle is in. And then we're going to state the first positive angle coterminal. Remember that the word coterminal means that it ends in the same place as the angle that you're given. So if we did degrees and you had 4,300 degrees, if this was a calculator question, what you could do is you could divide by 360 and get a decimal. If you divide it by 360, you get 11.94 repeated, which means it's not quite 12 times around. It goes 11 full times around. And then not quite 12 times around. Is that a good visual? Does it hypnotize you a little bit? You like math. You really like math. Okay. Now, because it goes 0.94 in that last decimal, 11 times around would end here, right? Because it's 11 full circles. And then 0.94 is a percentage, 94% around. Does it make sense that this is halfway around, so that would be 0.5? Here we have a quarter away around. Here we have 3/4. And so 0.94, because it's between 0.75 and 1, tells us that it has to be in quadrant 4. So that's if you have a calculator. If you didn't have a calculator, what you could do is keep subtracting 360 degrees until you get close. Probably what I would do is I would start by subtracting 360 degrees 10 times, because that's easy to do in my head, and see what I get. 4,300 minus 3,600 leaves me with 900 degrees. 900 degrees would be coterminal with 4,300 degrees. I could subtract 360 two more times, and then that would be what did I do? Oh, it's 700. Yeah, not 900. Thank you. Something seemed awfully wrong there for a second. 700. So I can only subtract 360 one more time, leaving me with 340 degrees. And so 340 degrees would be the first positive coterminal angle. Now, if you had done this on your calculator, what you could do is take the 0.944. So for example, if I pull up this on my calculator, and I just take the decimal and times it by 360, it'll tell me 340 as well. But I'll show you what that'll look like. So I took 4,300 and I divided by 360. We got that 11.944. If I just want the 0.944, can you see that I could just subtract 11? That'll give me just the 0.944. If I multiply that by 360, it gives us exactly 340, because that's the percentage of the whole that that angle would be. So that's using your calculator. So generally speaking, we've talked about if it's between 0 and 0.25, it's quadrant 1. The decimal is between 0.25 and 0.5, it's quadrant 2, and so on and so forth. And there we have the fact that there was 11 full rotations. We subtracted 360 11 times from 4,300 and got 340 degrees. So that's looking at degrees. With radians, especially if your radian is given to you as an exact value, then it's probably going to be a non-calculator type of question. Of course, you could do the same thing if you had your calculator, but instead of dividing by 360, you'd divide by 2 pi. And then you'd do the same idea if you divided by 2 pi. But if they give you an exact answer, exact angle, like negative 23 pi over 6, the technique that I find very helpful is to change it to a mixed fraction. So negative 23 over 6 is negative 3 and 5/6. Now we have to be careful here because we're not, the negative 3 doesn't mean negative 3 times around, because it's negative 3 and 5/6 pi, and pi is only halfway around. Does that make sense? Because when you get to pi, that's only 180 degrees. That's halfway around. So if you went negative 3, that means 1 pi, 2 pi, negative 3 pi, and then whatever the fraction is, if that fraction is bigger than a half, that means you'll go past half and end here. And since it was a negative angle, I'm thinking about going in the opposite direction. That's going to end in quadrant 1. The nice thing about figuring the first positive coterminal angle, what family is this part of? It's part of the pi over 6 family. So if you end it in quadrant 1 and it's part of the pi over 6 family, you know that the first positive angle coterminal with it will be pi over 6. And so you can do that kind of math a lot quicker in radians than you can in degrees. Okay, we'll do one more together. We'll do a positive one. We'll do 37 pi over 4. If you change that to a mixed number, 37 over 4 is equal to 9 1/4 pi. If you think about your unit circle, can you see that 9 pi is going to end right there? Because it's an odd number. Odd numbers are always going to be coterminal with pi. Even numbers are coterminal with 0 and 2 pi. And then if you went another quarter further, you would end up in quadrant 3. What's the pi over 4 family member in quadrant 3? Pi over 4. How many people are using the strategy of having one more than the denominator for quadrant 3 angles? So that helps you figure that out quickly. Oh, it's pi over 4 in quadrant 3, 5 pi over 4. Mental math with the unit circle. Sine of 7 pi over 6. The way that I would think through this is I would say to myself, do I recognize the family? The family is going to be pi over 6. So I know that sine of pi over 6 is a half. So then now I just have to think, well, what quadrant is 7 pi over 6 in? It's in quadrant 3. Is sine positive or negative in quadrant 3? Negative. So sine of 7 pi over 6 will be negative a half. So first of all, I know my pi over 6 family for sine is a half. Then I just have to say I know this is in quadrant 3 and sine is negative in quadrant 3, so I'll get negative a half. Tan of 2 pi over 3. First of all, for pi over 3 and tan, I know that it's equal to square root of 3. What quadrant is this in? Quadrant 2. Is tan positive or negative in quadrant 2? Negative. Cos of 7 pi over 4. Well, pi over 4. What's cos of pi over 4? Root 2 over 2. What quadrant is this in? Quadrant 4. Is cos positive or negative in quadrant 4? Positive. We're done. Now, once we get to the other ones, the reciprocal functions like secant, cosecant, and cotangent, what we can do is we can first figure out, well, since secant is related to cos, we can figure out cos of the angle. Notice I didn't flip the angle. We never change the angle. Pi over 4 family for cos is root 2 over 2. What quadrant is negative pi over 4 in? It's in quadrant 4. So will it be positive or negative? Positive. So then this will stay root 2 over 2. When we do the reciprocal, you get 2 over root 2. If you rationalize the denominator, you'll get root 2. But you could leave your answer as 2 over root 2. Because you might remember that when we initially did root 2 over 2, we had 1 over root 2. And if you flip 1 over root 2, you just get root 2 over 1. Cotangent, negative 11 pi over 6. Well, let's think of tangent of negative 11 pi over 6. What do we know tangent of pi over 6 family? Root 3 over 3. Maybe use that strategy that 3 plus 3 equals 6 to help you remember that. What quadrant is negative 11 pi over 6 in? Quadrant 1. So all things are positive in quadrant 1. So our answer for tangent of negative 11 pi over 6 will be positive root 3 over 3. Cotangent then will be positive 3 over root 3, which if you rationalize is root 3. Again, we can flip the answer, the ratio, but we don't flip the angle ever. So I kept the angle exactly the same, but my answer for tan was root 3 over 3, so my answer for cotangent of the same angle will be 3 over root 3. Cosecant of negative pi over 2. We think of sine of negative pi over 2. That's part of our axes family. Think of your 4 quadrants. Okay, negative pi over 2 is down at the lowest point. Sine is which coordinate, x or y? y. What is the y coordinate down at that lowest point? -1. So cosecant will be 1 over -1, which is the same. So on the exam, you often get these questions in an expression like this. Find the exact value of secant 11 pi over 3 times cos of -5 pi over 4 times tan of 23 pi over 6. Two of these we could do directly, cos and tan. For the secant, off to the side here, I'm going to figure out what cos of 11 pi over 3 is. So again, we go through the same idea. We say it's part of the pi over 3 family. Since it's part of the pi over 3 family, I know that cos of pi over 3 is a half. What quadrant is 11 pi over 3 in? Okay. If you change it to a mixed fraction, you're going to get 3 2/3. And if you think about ending at 3 pi and going another 2/3, you'll go past half. It's going to end in quadrant 4. So because it's in quadrant 4, cos is going to be positive. So cos of 11 pi over 3 is 1/2. That means secant 11 pi over 3 will be 2 over 1. Next we have cos of -5 pi over 4. First of all, we know that it's going to be root 2 over 2 because that's part of our cos family. -5 pi over 4 ends in quadrant 2. Is cos positive or negative in quadrant 2? Negative. So we'll add a negative there. Finally, tan of 23 pi over 6. We know that pi over 6 family is root 3 over 3. 23 pi over 6 is the same as 3 5/6. And you see that 3 would end here again, and 5/6 is more than half. So we'd end in quadrant 4. Is tan positive or negative in quadrant 4? Negative. Now we just need to simplify our fraction. These 2's will cancel out. Negative times a negative is positive. Root 2 times root 3 will be root 6 over 3. Sometimes these questions, instead of multiplying, they have adding, so then you need to get common denominators, but it's the same idea. And on the sheet that you had Friday, there are some questions like this near the end. So that really get you to practice these. So now that we have our unit circle almost memorized, or at least we have it in front of us, we can now do a number of trig questions without our calculator. The way that we do them without our calculator is you have a question like this. First of all, you know you need to do it without a calculator on your final exam because it's on the non-calculator part. And it looks like this. Solve for theta. Sine of theta equals negative root 3 over 2, and we're given a domain. First of all, how do I know this question is in radians and not degrees? Doesn't say. There's no degree sign here, and also it's telling us to solve between 0 and 2 pi, which is, there's no degree sign. Also, those are typical measures to use in radians. When it says to solve between 0 and 2 pi, does that make sense that they're looking in all 4 quadrants? Because you're going once around the circle in the positive direction. Do you recognize root 3 over 2? Is that ever a y coordinate? What family member do you have a y coordinate of root 3 over 2? Pi over 3 family. And since it's negative for sine, what quadrants are you going to be looking in? So we can make a note. We already decided that our reference angle, because our family is going to be pi over 3, and because it's negative, it's going to be in quadrants. Quadrants 3 and quadrants 4. What are our pi over 3 family members in 3 and 4? And so now we took out a lot of the calculator stuff that we normally would have had to do. Now, if this was a degree question from grade 11, you would draw it in quadrant 3 and 4. You would draw your triangles, and you would label opposite root 3, hypotenuse 2. You would find your reference angle, and you'd find it to be 60 degrees. Once you found it to be 60 degrees, you would have gone 180 plus 60 and got 240. And in quadrant 4, you'd have done 360 minus 60 and got 300. But now we can do them directly just using our unit circle. Recognize what family it belongs to, what quadrants it's in, and state the answer. So we're going to solve each of these one time around between 0 and 2 pi. Cos theta equals -1. Is the x-coordinate ever -1? Yes. Only once. It's at pi. And this is all the work you'd have to show. Is tan ever equal to 1? What family? It's pi over 4 family. When is tan negative? Quadrant 2 and quadrant 4. So the pi over 4 family in quadrant 2 and the pi over 4 family in quadrant 4. Secant theta equals 2. Again, with any of the reciprocal functions, what we're going to do is we're going to write out the regular function by doing the reciprocal of the answer. So if secant theta is equal to 2, that means cos of theta is equal to 1/2. What family does cos theta equal 1/2? Pi over 3. One thing that I find really helpful is I know that cos is equal to 1/2 at either pi over 3 or pi over 6, and sine is equal to 1/2 at one of those two. So I just memorize one of them and memorize one well. So I know that sine of pi over 6, sine of 30 degrees is 1/2. Then I look, oh, that's not sine, so then I know it has to be the other one, the 60 degree. I don't know if that helps you or not, if you can memorize a little bit less, but I find that that's helpful. So we know that pi over 3 is our reference angle. What quadrants will this one be in? Quadrant 4 and quadrant 1. So we list the family members in quadrant 1 and quadrant 4. And where cos is positive, secant will be positive. So secant follows the same cast rule as cos. Cosecant will follow the same cast rule as sine. And cotangent will follow the same cast rule as tangent. Ooh, a little bit extra work on this one. You have to first move everything over and get sine theta by itself. Can you see that if you did that, you'd get -1/2? Subtract 1 on both sides, divide by 2. Now that sine theta is -1/2, do we recognize what family that is? Pi over 6. What quadrants is sine negative in? 3 and 4. So in quadrant 3, we have 7 pi over 6. Quadrant 4, 11 pi over 6. So those ones were all straightforward ones. We also get to ones that are quadratic. And we have to remember how to factor. So if we have cos squared, and when we write a trig function squared, we put the squared in between the word and the angle so that you don't get it confused with the angle being squared. So if we have cos squared minus cos, this is like solving x squared minus x. How would you solve x squared minus x if you had to factor? Can you see that there's a common factor of x you could take out? So if you were solving this one, you'd factor out that x, leaving you with x minus 1, and then you'd solve it. We do the same thing with sines and coses instead of x's. What's in common between cos squared and cos? A cos. And you factor out that cos, leaving you with cos minus 1. Now, if we were solving with x's, you'd say x equals 0 and x equals 1, and you would be done. With sines and coses, you do the same thing. You'd say cos is equal to 0 or cos is equal to 1, but we're not done. Now we have to actually figure out what angle that is. Is our x coordinate ever equal to 0 on our unit circle? Hello?
Never mind.
Okay. So yes, the x coordinate is equal to 0. When is the x coordinate equal to 0? Pi over 2 and 3 pi over 2. Is the x coordinate ever equal to 1? Yes. At 2 pi? Anywhere else? Also at 0. So one thing to be careful with here, you see these symbols less than or equal to, less than or equal to? If the equal signs are there, you have to include 0 and 2 pi. If the equal signs aren't there, then 0 and 2 pi wouldn't be included in the domain. So I think I often see questions in the textbook where it would look like that. One of them's included but not the other. So then your answer would only be 0 and not 2 pi. So one thing that is a very good habit to do always, and one thing I'll recommend, is solve between 0 and 2 pi, including 0 and 2 pi every single time you solve a question. But once you're done, go back and look at the domain and say, are they asking me to solve everything between 0 and 2 pi? Because sometimes they'll say negative 2 pi to 2 pi. Then you have to do more answers. Or sometimes they'll say just from pi over 2 to 3 pi over 2, which is just quadrant 2 and quadrant 3. Then you have to go back and maybe take out some answers. So whenever you're done, re-look at your domain and make sure that your answers fit with the domain that you were given. Now, how would you solve a question, a quadratic equation that looked like that? X squared minus 3 over 4 equals 0. Could factor that. How would you, that one's a little bit tricky to factor because it looks like a difference of squares, but 3 over 4 isn't a perfect square. Okay? You could get the x squared by itself. And then what would you do? Square root both sides. What mistake did I do? I forgot the plus or minus. So we're going to do the same thing here. We're going to get sine squared by itself. We're going to square root both sides, which will just give us sine theta. We'll remember the plus or minus. How do you simplify square root of 3 over 4? That's the same as the square root of 3 over the square root of 4. But instead of writing square root of 4 on the bottom, it's just 2. Is that value on your pie plate? What family? What's our reference angle? pi over 3. What quadrants are we going to look in? It's positive or negative. You're going to look at all of them. This is what we call a family gathering. Everybody's invited. There we go. All 4. So how would you solve this if this was x's? 2x squared minus 3x plus 1 equals 0. Now, eventually, I'm going to not get you to think in x's, but it's just to trigger your memories. So how would you solve 2x squared minus 3x plus 1? What would be your first step? Factor. So we do the same thing here. Our first step is factoring. Set up your brackets. How do you get 2 sine squared? What's the only way to get 2 sine squared? You've got to have one of them be 2 sine and the other one be sine. In fact, whenever I'm factoring, for the most part in grade 12, they never give you really difficult ones to factor. So if you think of using FOIL, when you multiply it out, your outside and inside ones always get combined for this middle term. Your first ones always multiply to be that first one. Your last ones always multiply to be that last one. So when you get something like 2 sine squared, when you're factoring, it's obvious it has to be 2 sine and sine, because that's the only thing that multiplies to give you that. When I look at my last one, which is a 1, this one's really easy, because what's the only thing that can multiply to give you 1? 1 and 1. Now you have to think about your outside and your inside. Can you see that my outside right now is going to be 2 sine? My inside is going to be 1 sine. I need them to equal minus 3 sine. Can you see that that can be done if they're both negative? Negative 2 sine plus a negative 1 sine will give me negative 3 sine. Once I've written everything out, I do a quick multiplication check to make sure that this works. Do I have 2 sine squared theta? Yes, I already know I have minus 3 sine theta. Is my last one still going to be plus 1? Minus 1 times minus 1, yes, is plus 1. Now we can split it up here. What would make this equal to 0? If sine of theta were equal to 1/2. What would make this equal to 0? If sine of theta were equal to 1. 1/2 on your pie plate? Yes. What family? Pi over 6 family. What quadrants? Quadrant 1. Quadrant 2. Is the y coordinate ever equal to 1? Yes, at pi over 2. So this question has 3 answers. All right. Those are the first level of questions. You ready for the second level of questions? Here we have negative 3 sine theta minus cosquared theta minus 3. So if we were thinking with algebra, this is like solving negative 3y minus x squared minus 3 equals 0. We have a problem. Do you see that you have 2 variables? When you have 2 variables and you have one equation, you can't solve it. So it's not possible, and you would have been, if that was the question with x's and y's, you would have said, I'm done. I can't solve this. It's like solving an equation of a line. Y equals 3x plus 2. Solve. You'd be like, I don't know what to do. Because all you can do is graph the whole line. And there's all the points on the line are all different solutions, but there's not one answer. There's a number of answers that work. So how do we solve this? If it was just x's and y's, you'd be done. But since it's sine and cos, we can use one of our big ideas. Because when you have two things that you don't know, if you think back to the units that you did on systems of equations, if you have two equations with two unknowns, then you can solve, either using your substitution technique or elimination technique. Does that ring a bell? So as soon as we use one of our big ideas, that becomes our second equation. And now we do have two equations with two things that we don't know, and we can use substitution or elimination to solve. In this case, we're going to use substitution. Looking at my original equation, I see that I have a cos squared in this equation, and I have a cos squared in this equation. In this equation, if I get that cos squared by itself, I can do that by subtracting sine squared on both sides. If sine squared plus cos squared equals 1, then cos squared equals 1 minus sine squared. And now I can go back to my original equation and where I had cos squared, what can I write instead? I can now write 1 minus sine squared instead. And what that does is it changes my equation. Once I distribute this negative, I'm going to get a plus sine squared theta. I still have minus 3 sine theta. Minus 1 minus 3 gives me minus 4 equals 0. Now I only have the one variable. Now I can see if I can factor. What times what will give me sine squared? Only way possible would be sine and sine. My last one's a 4. I need to have two numbers here that multiply by 4 to get 4, but my outside and my inside need to make 3. So one thing that might work is 2 and 2, but if I did 2 and 2, can you see that my outside and my inside, 2 plus 2 or 2 minus 2, never equals 3? So I'd have to use 4 and 1 because that makes outside and inside with 4 and 1 can get 3. I need a negative 3, so I'd need my 4 to be negative, my 1 to be positive. Do a quick check. Do I still get everything if I multiply this out? Yes, I do. And so now we get the following. Are both those values on our pie plate? No. One of those values on our pie plate? Yes. So let's do that one first. When is the y coordinate equal to negative 1? Three pi over 2. So if the value is not on our pie plate, that often means that you'll need your calculator. So now you have to figure out with your calculator what this is going to be. So now you have to rethink, how did I do with a calculator in the past? Because up till now we haven't had to use a calculator. And make sure you type it in correct. I don't want to see any errors on your calculators. You went to your calculator, you tried to find your reference angle by doing sine inverse of 4, and you keep getting an error. Why are we getting that error? Why? Well, maybe let's draw a picture to help us visualize this, right? We are trying to find a reference angle. It could be in quadrant 1. Let's draw it in quadrant 1. Let's make the opposite side 4 and the hypotenuse 1, just because that's what that fraction means. And why can't we find that angle? Sine can't be great. Why can't sine be greater than 1? Because the opposite over hypotenuse would be 4 over... Can you see why that triangle doesn't make sense? When was the last time you saw a hypotenuse less than the side? Ooh. Right? So this question is still a non-calculator question. You have to recognize that when you got sine theta equals 4, that without your calculator, you know that that's not possible. So you need to indicate somehow that this is not possible, that there's no solution. Just leaving it blank will lose you marks, because they don't know if you know it's not possible or just didn't know how to do it. So you have to make some kind of indication that this side is not possible, that there's no solution, and that your only solution is 3 pi over 2. So this was the next level of question because you had to use one of the big ideas to substitute first. So whenever you get a question that has sine and cos in it, and one of them is sine squared or one of them is cos squared, you can use the identity, the big idea that sine squared plus cos squared equals 1. In trigonometry, we use the word identity to represent a trig equation that's always true. And since sine squared plus cos squared is equal to 1, that's called an identity. Tan theta is sine theta over cos theta. That's another identity. So since that's always true, we can use that and substitute in and then solve. This question would still be a non-calculator question because all of it, even though 4 is not on your pi plate, you need to know that both sine and cos can't be bigger than 1. If it was tan, that's okay for tan. But just sine and cos, you can't have a hypotenuse less than one of its sides. Here's an example of a question that would be on a calculator part. Usually what they do on these questions, they say, write your answers as exact values when possible, or round to 2 decimal places. So in this one, for solving for theta, again, anytime you're solving a quadratic equation, you need to make it equal to 0. And when you go to factor this one, since 6 can be 2 and 3 or 6 and 1, I would probably start by putting 1s here because I know that that's the only way that I can multiply to get 1. And then when I start to think what needs to go for my first terms, I'm also thinking my outside and my inside have to equal 1. So you can see right away it can't be 6 and 1. Because if I used 6 and 1, my outside and my inside would be 6 and 1, and I never get 1. But if I use 3 and 2, that can give me 1. I would need my 3 to be positive, my 2 to be negative. Do a quick check. Does that multiply out to be what it should be? Yes, it does. We get sine theta equals 1/2, negative 1/2. And here sine theta is positive 1/3. Are any of these values on our pi plate? Yes, the 1/2 is. That is part of our pi over 6 family. Since it's negative, it's quadrant 3 and quadrant 4. But the other one, sine theta is 1/3, is not part of our unit circle. So then we're going to have to go to our calculator. If you want to visualize it with a picture, you can draw it in quadrant 1 or quadrant 2. You can label opposite over hypotenuse and say, I want to find that reference angle. How do I find that reference angle? by doing sine inverse of 1/3. Unfortunately, I have that value memorized in radians. It's 0.34. Means you've taught math too long. So if our reference angle is 0.34, should double check that because my memory's been going lately. It's right? Okay. If our reference angle is 0.34, what are our angles? Does it make sense in quadrant 1 it will also be 0.34? In quadrant 2, you would have to do pi minus the reference angle. So pi minus the reference angle, rounded to 2 decimal places, would be 2.80. We'll end there. Remind me at the beginning of next class, the only type of question we haven't done yet are calculator questions where you start off with a quadratic like this, but it can't be factored, and you have to use the quadratic formula. Those ones are really pretty. So we'll do those ones after.